Welcome to Lesson 5 of Module 1 on Data Warehouse Concepts and Architectures. I'm going to start with an important business question about data warehouse development in organizations. Why is it difficult to go from the teenager stage to the adult stage? As you will see, this question involves the maturity model for data warehouses, a key tool to understand deployment of data warehouses in organizations across time. Lesson 5 continues with informational background about data warehouse development from Lesson 4. Lesson 5 presents business architectures and the maturity model to apply the insights from learning curves described in Lesson 4. You should remember this background as you get immersed in the details of data warehouse development in Modules 3 and 4. You have 3 learning objectives in this lesson today. You should be able to compare characteristics of the 2 opposing architectures for data warehouse deployment. In your own words, you should be able to explain insights from the data warehouse maturity model. Using the background from Lessons 4 and 5, you should reflect on the relationships between project challenges and architecture choices, especially with the insight from learning effects. When applied to computer systems, architecture refers to the organization of components to support specified goals. For data warehouses, business goals drive technology choices, so architecture is primarily a business issue, not a technology issue. The scope and integration level are important factors in determining an appropriate architecture. Scope refers to the breadth of an organization supported by a data warehouse. Scope can be measured in various ways, such as the number of data sources used, number of source systems providing inputs, or number of organizational units providing inputs or using a data warehouse. The integration level refers to several data quality indicators across data sources. Integration level involves completeness, consistency, conformity, and duplication across data sources, not within individual data sources. 2 opposing approaches provide limits on architectures for data warehouses. The top-down approach, known as the enterprise data warehouse, provides a single data warehouse for an organization. Through logical centralization, the top-down approach has a high level of integration and large scope. The bottom-up approach provides independent data marts with lower integration levels. A data mart is a data warehouse with a small scope justified by tangible benefits from critical business reporting needs and lower development risks from smaller project sizes. This diagram depicts a top-down architecture with 3 tiers: staging area, data warehouse, and data marts. The staging area provides temporary storage of transformed data before loading into the data warehouse. The staging area is particularly useful for data warehouses with a large number of operational databases and external data sources, requiring complex data transformations. To assist with the transformation process, the design process creates an enterprise data model known as an EDM. The EDM defines the structure of the data warehouse and details required to access operational databases and external data sources. Departmental users generally need access to small portions of the data warehouse instead of the entire data warehouse. To provide them with faster access, while isolating them from data needed by other user groups, smaller data warehouses called data marts are often used. Data marts acts as the interface between business analysts and the enterprise data warehouse, storing a derived part of the data warehouse and refreshing this derived part on a periodic basis. Generally, the data warehouse and data marts reside on different servers to improve performance and fault tolerance. Organizational units retain control over their own data marts, where the data warehouse remains under control of the corporate information technology staff. Some organizations believe building a data warehouse may be unnecessarily delayed with lost business opportunities if too much emphasis is placed on first creating an enterprise data model. Instead, some organizations employ a bottom-up approach to data warehousing, as depicted in this diagram. In a bottom-up architecture, important business reporting requirements spanning operational databases drive the development of independent data marts. Each data mart is relatively small in scope, supporting several organizational units and data sources. The integration is limited because of the small scope of data marts. The set of data marts may evolve into a large data warehouse if the organization can justify the expense of building an enterprise data model. One approach known as a data mart bus approach, provides an additional layer of data integration to transform selected data from independent data marts. The level of data integration in the data mart bus approach is much less than the level in an enterprise data warehouse. For highly decentralized or independent organizations, the federated data warehouse architecture provides another compromise approach. As depicted in this diagram, the federated data warehouse architecture supports two levels of data warehouses. Each organization independently maintains one or more data warehouses using any of the architectures. To provide interorganizational sharing, each organization contributes to the federated data warehouse. Typically, another layer of data integration and a query portal support data sharing in the federated data warehouse. Depending on the environment, participation can be voluntary or compulsory, typically required by government agencies. Primary users of a federated data warehouse are external stakeholders, not members of participating organizations. Learning effects provide bias for data warehouse projects of smaller scope. Intangible business value creates uncertainty about return on data warehouse investments, especially data warehouses with wide scope. Project risks provide uncertainty about costs for data warehouses with a wide scope. Learning effects typically postpone benefits while incurring cost early. Over longer periods, these learning difficulties can be mitigated, however. To overcome the bias for smaller data warehouses, senior management should develop a high strategic view of information technology. The strategic view is influenced by the level of sponsorship, information independence, and task routineness. Organizations with wide level of sponsorship for projects, information dependence for long-term decision-making, and lower task routineness will have a higher strategic view, favorable to the enterprise data warehouse approach. Maturity models are commonly used as a roadmap to evaluate and understand an organization's progress over time, especially for technology capabilities and deployment. Immature organizations exceed budgets and deadlines, focus on immediate problems rather than strategic problems, lack criteria to evaluate quality, and do not enforce standards. The data warehouse maturity model, proposed by Eckerson in 2007, consists of 6 stages as summarized in this table. The stages provide a framework to view an organization's progress, not an absolute metric, as organizations may demonstrate aspects of multiple stages at the same time. As organizations move from lower to more advanced stages, increased business value can occur. However, organizations may have difficulty justifying significant investments, as benefits are sometimes intangible with quantifiable benefits delayed. The data warehouse maturity model provides a framework to view an organization's progress and to guide investment decisions. It is not an absolute metric, as organizations may demonstrate aspects of multiple stages at the same time. An important insight of the maturity model is the difficulty to move between certain stages. For small growing organizations, moving from the infant to the child stages can be difficult because a significant investment in data warehouse technology is necessary. Larger organizations typically struggle to move from the teenager to the adult stage. To make the transition, senior management must perceive the data warehouse as a vital enterprise resource, not just a tool provided by the information technology organization. This lesson provided more background about data warehouse deployment in organizations. You learned about characteristics of 2 business architectures, the top-down and bottom-up architectures, and the data warehouse maturity model. The architectures differ on scope and integration levels. The maturity model provides a roadmap to understand an organization's progress in developing data warehouses to support business intelligence. In answer to the opening question, the data warehouse maturity model provides guidance about moving between stages that can inhibit effective usage of data warehouses. Many organizations have experienced difficulties moving from the teenager stage with data warehouses for divisions to the adult stage with an enterprise data warehouse driving the entire organization. To make the transition, senior management should develop a strategic view of business intelligence, especially to recognize learning effects when increasing the scope of a data warehouse. Overcoming fixed cost of learning will reduce transformation cost, but unlock intangible business value. Essentially, costs are incurred earlier, but business value is released later in deployment of an enterprise data warehouse.